Good day to you all, and welcome to another training module from Operators Unlimited. I am David Collier. If you have any questions during this presentation, my contact information is on the right side of the screen. In this module, I'm going to talk about sampling. I'm discussing the general ins and outs of sampling. Your site or organization may have specific details not included in this presentation. One sample is not adequate for every situation. Generally speaking, we use two types of samples: process control and regulatory. Procedures need to be in place for both. These procedures need to include the point of sample collection, the type of sample container, the method of collection, and the order of collection with consideration to hold times. There are hold time issues for pH, DO, temperature, TRC, and fecal coliform. Employees collecting samples must be trained before working independently. Samples should be tested as quickly as possible after collection to reduce degradation. Most wastewater operators will collect and analyze their process control samples to verify proper operational control. The analysis will provide data to make daily adjustments supporting effluent discharges that meet permit requirements. These sample results need to be recorded internally to aid in identifying future trends or troubleshooting operational issues. Regulatory samples will sometimes be collected by the wastewater operator, but may be collected by a laboratory sample technician. These regulatory samples must meet the requirements defined in your discharge permit. Samples must be collected at the sample point called out in the discharge permit. They also must be collected using the method called out in the discharge permit, whether it's a grab or a composite, and according to the schedule in the discharge permit, 5 times a week, Monday through Friday, is an example. All regulatory samples collected from the certified location must be reported to the governing agency if testing is completed by a certified lab. Now let's talk about collecting a representative sample. The goal of any sampling procedure is to collect the proper volume of wastewater that accurately represents the larger wastewater stream that you are sampling. Simply said, a representative sample is the same as the laboratory results from a small sample that you would collect are the same as they would be if you had measured the entire flow or volume. A good analogy is a pot of soup that you are tasting with a spoon. If the spoonful of soup tastes the same as the whole pot, it is a representative sample. Mixing is especially important to maintain a homogeneous sample. What methods do we use to collect samples? Two methods are generally used: a grab and a composite. The grab sample is a one-time event. A composite sample is a mixture of grab samples to represent an average. Either type may be attained manually or automatically, although composite samples are usually collected automatically and grabs are usually collected manually. Let's talk in more detail about the grab sample. A grab sample is a single sample collected manually at a single location. The grab sample is called a discrete sample. It shows the wastewater characteristics only at the time and place of the sample collection, a snapshot. Some sample constituents require a grab sample due to sample degradation. pH, TRC, DO, cyanide, volatiles, and others. Other constituents can be tested with a grab sample for quick checks, but are not considered to be a representative sample for the entire day. Now we're going to talk about the composite sample. In a typical municipal wastewater system, wastewater quantity and quality change hour by hour. A single sample collected at a single time will rarely be representative of the average daily condition. For this, a composite sample, also called a proportional sample, is required. A composite sample is made by collecting several small grab samples and collecting them in a common container. The rate at which the grab samples are collected is driven by the flow rate or time. Different types of sampling will require different types of equipment and methods. So we're back to the grab sample. Manual sampling equipment for grab samples include dippers, weighted bottles, hand-operated pumps, and cross-sectional samplers. Dippers consist of wide-mouth, corrosion-resistant containers such as a can or a jar mounted on a long pole. Some commercial dippers are made to hold standard sample bottles, which saves the trouble of having to pour the sample off after it is collected. A weighted bottle is a collection container designed to collect water from a specific depth. After it is lowered to the desired depth, a cord or wire is pulled by the operator, removing the bottle stopper so that the bottle fills. There are various types of small pumps that can be adapted for drawing samples from tanks or channels. They include hand-operated or electric, suction type pumps, and peristaltic pumps. One advantage of collecting using a pump is that the operator has better control over depth and the location of the sample collection. A cross-sectional or core sampler is used to sample when the wastewater or sludge may be in layers, such as in a digester or a clarifier. The sampler consists of a tube open on both ends that is lowered into the water. When the tube is at the proper depth, the ends of the tube are closed by a mechanism. The trapped sample is representative of both content and physical orientation. Your samplers need to be constructed of what material? That's a good question. Whether automatic, manual, grab, or composite, samplers need to be made of materials that are compatible with the constituents being analyzed. Some analyses have special requirements called out in the standard methods for the examination of water and wastewater. These special needs should be part of the procedures mentioned earlier. Some consumable items needed are your PPE, your ice chest, tubing, sample containers, dipper, and a chain of custody. The most common container is plastic, followed by glass. Glass containers are needed for oil and grease and many organic substances because these constituents will stick to the plastic and bias the sample. Microbial samplers must be made of a material that can be sanitized. Sample handling. The goal of a good sampler is to deliver the proper volume of a representative sample to the laboratory. The sample can change due to chemical reactions, biological breakdown, coagulation, absorption, and settling. These changes may affect the sample results. Sample preservation, storage, and transportation. For most wastewater samplers, deterioration starts immediately after collection. This means that the shorter the time between collection and analysis, the more reliable the results will be. In many cases, laboratory analysis cannot be started immediately. Acceptable EPA methods to preserve various kinds of samples are shown in the preservation chart. You can see in the table that refrigeration is commonly required. Acidification, meaning adding acid, is another common preservation technique. These techniques slow the biological and chemical reaction, but do not stop them completely. Samples cannot be stored forever. The preservation chart also lists maximum hold times. Analytical results from samples that have exceeded the maximum hold time are considered unreliable. Note that some constituents such as temperature, pH, dissolved oxygen cannot be stored at all and must be analyzed immediately at the plant site. I'm pulling up the chart that shows our test, what we're analyzing for, the type of the container, the method of preservation, and the maximum hold time. BOD is a common analysis. We can collect that in plastic or glass. It must be stored at 4 to 6 degrees, and we can hold it for a maximum of 48 hours. This means that we don't want to collect a BOD sample on Friday afternoon. By the time we come in Monday morning, the sample will have exceeded its maximum hold time, and thus the sample would be invalid. Now, if we want somebody to test it over the weekend, that's another story. Dissolved oxygen, you can get that in a glass container. There is no hold time, and you must analyze that within 15 minutes. Nitrates, plastic or glass, refrigerate at 4 to 6 degrees, 48 hours maximum hold time. pH, plastic or glass, 4 to 6 degrees C, 15 minutes hold time. This is a field analysis. We're going to test it in the field. TKN, that's plastic or glass. You're going to acidify it with H2SO4, which is sulfuric acid. You're going to drop the pH to less than 2, and you're going to cool it from 4 to 6 degrees C, and you can hold that sample up to 28 days. This chart, I typically put it out in a handout, so hopefully you have that. Samples that are transported or held must be cooled and or refrigerated to 4 to 6 degrees C. This means you will need an ice chest with ice to transport cold samples from the field. Chain of custody procedures. The chain of custody is a document, and you record each person involved with the collection, handling, and possession of each sample. The chain starts with the person who collects the sample and continues to the person who analyzes the sample in the laboratory. The chain of custody procedure helps ensure that samples are handled correctly, and it is very important when samples are sent to an off-site laboratory for analysis. The chain of custody form will state the sample ID, the date and time the sample was collected. This is so you can watch your hold times, the type of preservation method used, and much more. The chain of custody must be relinquished by one person and received by the next person, showing ownership of the samples at all times. I have an example of a chain of custody. Every lab or organization will have their own chain of custody. This particular one here is Rogers and Callcott. You will have the name of the company, you'll have the ID, you have the date, the time, and a description of the sample. You will have all of your codes filled out, whether it was filtered, whether it's cooled, the container type, the container volume, the sample type, whether it's composite or grab, the sample source, wastewater, groundwater, drinking water, and whatever your preservation code is. This will have to be done for each container. Down at the bottom, you will have a part where the sampler fills in his or her name, the date and time. Okay. Then when they relinquished it, who it was relinquished to, and the date and the time, and everybody has to sign it as it goes through the system. After the analysis is completed, you will get a copy of this document, and it will have everybody who has possessed the sample on the bottom, and that is your completed chain of custody. Lab analysis. If your samples were sent off-site to a laboratory for analysis, you will receive a laboratory analysis report explaining sample results, quality control procedures, and a completed copy of the chain of custody. This report will list each constituent that was analyzed, the lab tech who analyzed the sample, the date and time analysis was performed, and the general analysis results, along with analytical notes. These reports are extremely important. Should there be an error, the error is yours, not the laboratory's. Time is critical, and resampling may be required before the end of the week or month, depending on your wastewater discharge permit. Why are standardized procedures important? Standard procedures are needed for both process control samples and regulatory samples for a couple of reasons. First, using standard methods ensures that everyone is testing the same thing the same way. If everybody used their own method, concern would grow about whether the results from different tests are comparable. Second, consistency of sample collection and analysis is critical to the building of accurate and reliable data. Regulatory samples must be analyzed by a South Carolina certified laboratory using EPA standard methods for the examination of water and wastewater. I'm going to talk about a little bit of strategy on regulatory samples. Sample as early as possible. This gives you options to resample if needed. If you sample every day, sample early in the day. If you sample once a month, sample early in the month. Sample only what is required. Any extra samples must be reported. If a resample is required, do not resample for all of the constituents. Only resample the constituents in question. I know and understand that we want to discharge high quality water that meets our discharge permit at all times, but be extra mindful of small details that may affect your regulatory samples. Take no chances. I wish each and every one of you the best of luck. Again, if you have any questions, my contact information is on the right-hand side of your screen. That completes this training module. I hope that you found the information to be beneficial, and I hope you have a wonderful day.